Hello and welcome to Math Lessons with Linda. Today's topic is logarithmic equations. We're going to take a look at a few examples, and this video assumes that you already know the properties of working with logs. If you don't, you may want to take a moment to go back and review that before you begin further with this video. Our first equation is 2 log of x equals log 2 plus the log of 3x minus 4. In this equation, we have logs in every single term, and also you notice that I didn't write a base for the log, which that implies it's a log of base 10. So what we're going to do first is combine logs and simplify with the exponent of the coefficient right here. So that looks like log of x, this 2 comes up and becomes the exponent, so it's the log of x squared. Over here, when we have 2 logs and we're taking the sum, we can rewrite it as one log statement as a product of the 2 arguments. So I'm going to have the log of 2 times 3x minus 4. Now at this point, I have a log statement on each side, and these logs are both the same base. So what I can do is I can drop the log statements and just put the arguments equal to each other. I'm going to go ahead and distribute through here. So I have x squared equals 6x minus 8. Now at this point, it just becomes an algebra problem for factoring. And before I do that, I need to move these 2 terms to the other side. So I'm going to get an x squared minus 6x plus 8 equals to 0. And that will factor into x minus 4 times x minus 2. And for each of these, I would set them equal to 0. And then I will solve. So I'm going to get x equals 4 and x equals 2. Now, the one thing to make sure that you check for in log equations, the solutions that you get may be positive or negative, that's okay. But what can't happen is up here in your original problem, all these values that you're taking the log of are called the argument. If you substitute any of your solutions that you got into these values, the ones with variables especially, if it's a negative argument, then you have to reject the solution because we can't have a negative argument in a log equation. So when I plug 4 and 2 both into these, they check out. So I end up having 2 valid solutions for this particular log equation. Okay, so let's take a look at another equation where we do something a little bit different and there is no log in our original problem. So this one is 3 to the x power minus 2 equals 12. There are 2 ways that you can do this problem, and it will depend on what your teacher will allow you to do in your class and what work you need to show. So the first way I'm going to do this is first I'm going to just treat it like a regular equation where I'm going to move my 2 over here, so I get 3 to the x power equals 14. Now, I know that there's no way in my head that I can come up with what x is because I cannot make 14 have a base of 3 and raise it to some power. So what I'm going to do is I'm going to take the log of each side of my equation. I'm performing an equivalent action. And notice that this is going to be a log base 10 that I'm doing. So one of my properties is I can bring out the exponent, which I need to solve for, and that becomes the coefficient. So what I'm really doing here is applying a change of base if your teacher has used that. I'm going to divide both sides by the log of base 3. So now here's where you need your calculator. You need to take the log of base 10 of 14 and divide it by the log base 10 of 3. When you do that, we are going to approximate. You should get about 2.402. If you take that value and plug it right back up here into your original problem for the exponent, perform that operation, subtract the 2, you should get 12 and it will check out. Now, that was one way, and I mentioned there's another way that your teacher might allow you to use your calculator and not show all the algebraic work. After you get to this point in the problem where we've added the 2 over and we have 3 to the x equals 14, this is written in exponential form. You can write this in log form, and then if you have a graphing calculator, you can go to the log base on your calculator and enter this in. The log form of this is log base 3 of 14 equals x. Since this is what we're solving for, you can enter this into your calculator, hit that button, and you are going to get the same answer as if you did it out algebraically and used the change of base formula. So this is dependent on what your teacher will allow you to do. Both give you the same solution. Okay, our last equation today is going to deal with natural logs, which you'll see sometimes written as ln. I tend to write it in cursive so that my L does not look like a 1 and I mistake it for something else. So the natural log of 4x minus 1 equals 3. Anytime you see a natural log, that implies that your base is e. And also on your scientific or graphing calculator, you will have a little e button. E is a constant, similar to like pi is a constant, and it's approximately 2.718. And your calculator knows this already. So what I'm going to do is, this is written in log form. So I'm going to just turn this into exponential form. So e to the 3rd power is equal to 4x minus 1. I use what I call the log loop, and I go in the order of my loop, and that's how I convert it into exponential form. So here's the variable we're trying to solve for. Remember, e is a constant. So I'm going to add 1 to both sides. So I have e to the 3 plus 1 equals 4x. Now I'm going to divide both sides by 4. So on your calculator, you should be able to enter this all on its own. You may want to put this numerator in parentheses. And when you solve for x here, you are going to get approximately 5.2714, however many digits you need to round off to in the directions. And again, if you plug this back into here and then you perform the operation, you should get this to check out as well. And those are a few different types of equations with logarithms and how you can solve.